Hi, and welcome to the first video on acoustics for recording, the basics. What I want to talk about in this video is just what acoustics is, why it matters, and how we can start to think about it in a way that takes the negative impact that it can have on our recordings out of them. So first of all, what is acoustics? The easy way to understand it is to just think of it as the study of and the understanding of the way sound exists and behaves in any given space where sound can exist. So for example, in a recording studio, a bedroom, a car, a forest, any of the environments that we might find ourselves in or want to record in for the purposes of sound design and kind of TV and movie sound recording. Why acoustics is important is because, although it's often overlooked, it has a massive impact on both the subjective and objective quality of your recordings. That's subjective in terms of simply whether or not people like them, and objective in terms of the clarity of the sound, how easy it is to understand, for example, somebody speaking from your recording, or to identify what the sound is actually supposed to be. And to give you an example of the impact that acoustics have on sound, I recorded a little demonstration of it. Now I'm recording with the exact same microphone. That's an AKG C214. I'm using the same recording device. That's a Zoom H6. And the microphone's about the same distance from my mouth. So the only difference here is that I'm speaking in a room that's not properly acoustically treated for sound recording. All the differences you can hear are generated by the room acoustics, and they're baked into the recording, and they are very difficult to fix in post. So you hear there the impact that just being in a different room can have on the recording you've made. I recorded that in a room with very obvious acoustical differences from the sound booth that I'm recording in now, just so that you'd be able to clearly hear it. But fundamentally, every environment has properties which change the acoustics of sound and therefore will change the quality of your recording. First of all, let's talk a little bit about how we can start to think about sound. What we're used to seeing, and probably what you'll remember from last year, is the common waveform view of sound. That's simply a two-dimensional graph, if you like, of what sound is and how it behaves. And it looks something like this typically, just a wave which cycles or repeats in pattern as it proceeds or goes along. This is quite useful for understanding a few things. We can, for example, understand the wavelength, which is closely related to the frequency of the sound, by looking along its length. We can also understand the intensity of the sound, which is closely related to its loudness, by looking at the height of it. And these should be terms that are at least somewhat familiar to you from last year, and I'm sure you've seen this kind of waveform view of sound before, represented here as a sinusoid, which is the correct name for that shape, that smooth, or at least as smooth as I can draw it, repeating cycle. It's very useful in those terms, but it's not the whole story. Sound is not a two-dimensional phenomenon, it's a three-dimensional phenomenon, and that's how we need to start thinking about it if we want to make good, competent, well-controlled recordings. So let's imagine a person, for example, any sound source, but in this case we'll use a person, who's about to start making some sound. When they begin to speak or sing or whatever it is that we've asked them to do as recording engineers, sound is going to begin to propagate or move or expand in the environment around them. And we can think of it as being like a bubble which expands outwards from the source in all directions. It doesn't necessarily expand equally in all directions from the source, but we can leave that for a more advanced video. For now, we can just imagine this bubble of sound expanding out from the source, and we can imagine that actually these lines I've drawn are the peaks or the high points in that wave that I drew before. So now we've got a slightly more three-dimensional understanding of the sound, or at least three-dimensional in as well as I can draw it, because I'm not an artist. I think that's probably clear. If we were going to be attempting to record this person, we'd also need a microphone in the environment with them to capture the sounds they were making. So I'm going to place a microphone by our, let's call them recording artist, just like so. And what happens is, as you would expect, Sound simply travels directly out of their mouth into the microphone. We call that direct sound in acoustics, incidentally. And that's fine, we get our recording and all seems well. But there's a problem here. This person appears to be floating in outer space, and everyone knows outer space is not an environment to record sound in. Ordinarily, they'd be in some environment, for example, a room, like this one. And what's going to happen to that sound is, even after it's passed by the microphone, it's going to continue travelling beyond it until it hits a boundary in the room. And just like light, sound reflects. So that sound is going to come bouncing back towards the microphone to be recorded. That is what you could hear in that example recording that I played you at the beginning of this video. The differences in sound of my voice as it was recorded there were all being created by reflections bouncing back from the environment and hitting the microphone. And it's not just walls that cause a problem. Sound will also reflect from the floor, from the ceiling. Oh, what a wonderful line. And in fact from all the other walls. And I could just carry on drawing this forever. You get the idea. Basically any solid object, and many soft objects like chairs and furniture, and even people, will reflect sound. And when that sound reaches your microphone, it will change the quality of your recording. Now, one problem we face is that when we're just standing in a room, listening to each other talking, or even if we do something like clap our hands to try to make some sound that we can listen to the acoustics of the room with, we're not always going to hear the echoes exactly as they are in that room. That's because of a phenomenon called echo suppression, sometimes referred to as the law of the first wavefront by psychologists. What that is a phenomenon where our brains will actually ignore sound reflections or echoes if they arrive within about 20 milliseconds of the direct sound. So in other words, if I make a direct sound to this microphone, or just in general in an environment, and the reflections get back to me within something like 20 milliseconds, my brain will ignore them. This actually makes sense from a natural perspective, because if you imagine primitive humans wandering through caves and the like, living in forests, we might come across a predator like a wolf, or rather it might come across us. We might hear it and know where it is from that sound. That's fine as long as you're not in an environment where there's lots of sound reflections. If you could hear all of those reflections, it would make it very difficult to know where the predator was. If the wolf's over here and it growls, but its voice is also being reflected from here, and I hear that, then I don't know where the wolf is just from sound. So that's the reason why our brains do it. I suppose evolution, or God, depending on which you prefer, didn't ever really account for us working in recording studios. So just because you can't hear a sound reflection in the room doesn't mean it's not there, and it doesn't mean it won't change the quality of your recording. There are lots of other phenomena associated with room acoustics, not just the echo itself, but properties of the echo, which I'll be talking about in more advanced videos. But for now, you just need to remember that just because you can't hear a sound reflection doesn't mean it isn't there, and it doesn't mean it won't affect your recording. So how do we minimize this problem? Well, one thing is to pick the right room to record in, if possible. Right now I'm in the media and sound booths up in Queens. We also have the CTS studios, the main recording studios in Queens, and of course the radio booths. All of those have been acoustically treated to some extent to try and minimise the amount of sound that reflects in them. We can't always record in those kinds of environments, particularly if we're working for film and television, and sometimes we don't even want to. So one other step we can take is to position as best we can the person or the sound source, whether it's a person or not, and the microphone in the right place. On that topic, what you can see here is actually the person and microphone in more or less the ideal place. That is to say, pretty much in the middle of the room, as far away as they can get from any reflective surfaces. A poor place to position our performer and our microphone would, for example, be in a corner, close to a wall. Why is that? Well, sound loses pressure over distance. In our terms, what that means is sound gets quieter the further it has to travel, and instinctively we all understand this. Sounds that are far away are quieter. If our person is standing very, very close to the wall, when they start to make sound, it only has a short distance to travel to the microphone. That's fine, but it also only has a short distance to travel to the wall and get reflected back. That means that the reflection is going to be quite loud and much more audible in our recording. So if we keep people away from things that make sound reflections and we keep the microphone away from things that make sound reflections, at least those reflections will be quieter and will have a smaller impact on our recording. Now, there are also problems associated with how far away a person stands from a microphone. And you might be surprised, or you might not, to learn that putting a person really close to a microphone is a bad idea, and that's not just because it might make it hard to get a recording that isn't too loud. There are actually acoustical phenomena that happen inside microphones when a person gets too close to them. But again, I'll leave that for another video. For now, what I will say is that generally speaking, having a person at least 10 centimeters away from the microphone usually prevents most of those problems. So if we keep our person and our mic 10 centimeters apart, and as a collective, the person and the mic as far away from reflective surfaces and objects as possible, our recording's probably got a good chance of being good. Thank you for listening.